Hi everyone, I am Yogadharani, working as Assistant Professor in Department of Computer Science Engineering at SNS College of Engineering. And in this video, we're going to see about analysis framework in design analysis of algorithm. Before going to the analysis framework, understand how to measure input size, how running time is quantified, and how different order of growth affect the order of growth affect algorithm performance is essential. This knowledge forms the foundation for choosing efficient algorithm, especially as the size of the problem grows. And first one, measuring input size. And then analyze the efficiency and algorithm when the initial step is measuring an input size. Here input size refers to the amount of data that an algorithm needs to process. The size of the input is usually represented by n, where n is the number of elements in the input. And then example for sorting a problem, the input size would be the number of elements in the list or array. And how it is measured means the input is often represented by a single number of n, but it may be a combination of parameters. Example, for a graph problem, we might consider both the number of nodes and edges as the input size. So for algorithm that works on the multiple inputs, the total input size could be combination of individual input size. And then second one is units for measuring running time. Here running time measures the amount of time an algorithm takes to complete depending on the size of the input. Here running time, big O notation is the most common way to express running time or time complexity in the algorithm analysis. Big O notation abstracts away constants and lower order terms to focus on the growth rate as the input size increases. O of 1 is the constant time, big O of n is a linear time, big O of n square is a quadratic time, and big O of log n is equal to logarithmic time, and big O of n log n is a linear time. And measuring units for running time is operations per second and real time. And then order of growth. Order of growth describes how an algorithm running times changes as the input size increases. This is often used to categorize algorithm into different time complexities. As I already told, constant time, linear time, quadratic time, cubic time, algorithmic time, linear algorithmic time, exponential time, and factorial time. And the last one is efficiencies like worst case, best case, and average case efficiency. When analyzing an algorithm's performance, it is essential to consider different scenarios based on the input. And the worst case complexity refers to the maximum time the algorithm could take given the worst possible inputs of size n. This is the most pessimist analysis of the algorithmic performance. Example, for a quicksort, the worst case occurs when the pivot always divides the array is the most unbalanced way. Example, the smallest or largest element each time, resulting in big O of n square time complexity. And why it is important means it gives an upper bound on the algorithmic's running time is usually used to assess the efficiency of an algorithm is the worst possible scenario. And the best case complexity means it refers to the minimum time the algorithm could take assuming the best possible input of size n. Example, in merge sort, the best case occurs when the array is already shorted. It would still take a big O of n log n time. However, algorithms like bubble sort might have a big O of n time complexity if the array is already shorted. And it is important at the time it provides insights into the algorithm's performance when things are going well. Example, shorted input, no duplicates, etc. And then average case complexity. The average case time complexity is the expected time an algorithm takes for the random input of size n. This assumes that the input is a random distribution and calculated the expected running time over all possible inputs. Example, for quicksort, the average case time complexity is big O of n log n, assuming that the pivot divides the input roughly in half. And why it is important? It provides a more practical estimate of how the algorithm performs on typical input, which is often the most relevant for a real world application. So these are the algorithms framework. Thank you.